Hello and welcome back to Machine Learning. I'm Jovita Christie, and in this video, we are going to implement some of the feature construction techniques that we learned in the previous video. So um, I would suggest that you go through that video first before coming to this one. So let's talk about adding a new feature. That was one of the things we studied, that you could add an altogether new feature from whatever features you already have. So that is what we are seeing now. So we are going to create our own features. We are not using any data set. So we have a room length feature, which contains all these room lengths. We have a room breadth feature, which contains all these breadths. You could put any number. And then we are having a room type feature, which specifies which kind of a room is big, which is normal. So 1820 is big, 2020 is big, 1010 normal, 1211 normal, 1819 big, 1110 big was normal. So that is our data. Once you have created 3 arrays, you need to create a Pandas data frame. So we are going to import the Pandas library and create our data frame by writing pd.dataframe, where we will specify what kinds of names we want for our columns. So I want one column to be length, and I want the data to come from the room length array. I want another column to be breadth, and I want the data to come from the room breadth array. I want the third column to be type, and I want that data to come from room type. And then once you print the data, you can see a very nice looking data frame that is perfectly arranged. Okay. Now, what kind of feature can you add? So from our example that we saw in the previous video, we calculated area from length and breadth. So you could do the same here. Area is nothing but length into breadth for this kind of a situation, because a room would be essentially a rectangle. So area of a rectangle is length into breadth, which gives you the area. Okay, so you just have to do this, data length into data breadth, and save that into another kind of column called data area. And it's as simple as that. Pandas is just going to add one more column to your data frame called area, which contains the multiplication of length and breadth. So this is what your data would look like. And this is how you can add a new feature. Let's next talk about encoding nominal variables. Nominal variables, once again, are variables that are categorical and have no meaning, no hierarchy. So here we have 2 arrays, age, which contains ages of different people, and the cities that they live in. So we have 3 different cities, A, B, and C. And once again, we are going to create a Pandas data frame. This time, we will be saving it into a data1 variable, just so we don't confuse it with the other one. And we're going to have the same columns, same named columns as our arrays, age and city. And this is our data frame right now. Now what we want to do is convert city into city, which is nominal. We want to convert that into some numeric value. So to do that, you can use the getDummies function of Pandas library, which is used to dummy code the categorical variables. Okay. And this is a very creative and very easy way to do what you want. So here you can see dummy features is equal to pd.getDummies. That's the function. And you are just going to pass into it data1 with the city column. Okay. Now, if you print out dummy features, you can see it's exactly like we saw in our previous video. You have city A, B, and C. And whenever for the first row it is city A, so this is 1, everything else is 0. For the second row we have B, so this is 1, everything else is 0. That's how you can have dummy features. Now all we have to do is add this in place of the city column in our original data frame called data1. So to do that, you first would want to take out the age column from your original data frame. So we are taking that out by using the pd.dataFrame, passing data1 as data, and the column that we want is age, so we're passing that here, and taking that column out and putting it into data age. So now data age is a data frame that contains only age. And now what we're going to do is combine age and this city or dummy features that we created. So you can concatenate. For that, we will use pd.concat, where we will pass data underscore age dot reset underscore index. Why we're doing this? Because we want this indexing to be proper. Okay. Usually we do this kind of a thing when we have deleted some of the rows and we want this indexing to be again from 0, 1, 2, 3, 4. But you could do it for this kind of a situation also. So we have all the indices correct. We are also passing the second data frame as dummy features. And we're writing axis 1 because we are dealing with columns, not rows. And so this modified data frame is now like this. So this is how you can convert your nominal data into numeric data. Now let's talk about what you can do with ordinal variables. So ordinal variables are also categorical variables, but instead of having numbers in this, you're going to have ordinal variables are categorical variables, but instead of having just class A, B, C, you will be having some hierarchy in the categories like grade A, B, C, D. There is a hierarchy. A is highest. Okay. So once again, we will create our own features and our own data frame, which looks like this. So you have marks of 2 different subjects, science and math. And you have the grades B, C, A, D, B. And we are creating a data frame out of this, which we will call data 3, where we will use science marks, math marks, and total grade as our column names, and these 3 arrays as the data. So this is a nice looking data frame that we have. And now for the encoding, Python provides a very nice function for this, which is known as label encoder, which you can get from preprocessing. And you just have to write preprocessing dot label encoder, and we will save that into LE object. Then you can write le.fit and just pass the column pass the categorical or ordinal column that you want to be converted into numeric data. So for us, we have the total grade column from data 3 data frame. And you just have to pass that and fit. And next, you're just going to change that column. So to change, you have to write data 3 total grade equal to, now you'll write le.transform. That is our another function, and pass the total grade again into this. And now when you print out data 3, you will actually see that it is transformed. Okay. Now, how did the transformation happen? So what happened was it took the value B, which is our first value, and converted it to 1. It took the next value C and it realized this is another different value, so it's converted into 2. There is A, which got converted into 0, D got converted to 3, B got converted into 1. So it is following some type of an alphabetical order and converting our values for us directly. You could also use the replace function if you wanted to give your own numbers. For example, maybe instead of making A 0, you want A to be 1, and you want to start your numbering from 1, then you could use your own numbers by using the replace function, and you could try that out by yourself just to see how that works. Okay, so this is how you can do it. And yes, I forgot to mention that to gain access to this label encoder and transform and fit, you need to import sklearn. From sklearn, you need to import preprocessing. So once you've done that, you will be able to perform all these functions. Okay. Next, we'll talk about transforming numeric or continuous features to categorical features. This we saw earlier, right? That we wanted to convert numeric features into categorical and then back to numeric. So how do we do that? So let's first define our features. So we have two columns, apartment area and price. These are the areas, these are the prices. They are the same prices we saw in our video in the previous in our previous video. And we're going to create a data frame out of this and call it data 4, where our first column is area, second column is price, and the data comes from these two arrays. And this is what your data looks like. Okay, so this is your nice data frame with columns and rows. Now next, what we want is to assign some features, to assign some categories to this kind of data. So how do we do that? So you can import the NumPy library for this. And this might be slightly new for you if you have been following all the machine learning programming videos, but it's not that difficult. What you are doing is, first of all, you want to make changes to the price column. So you're just writing data for price equal to, and then you're going to write all of these things, okay? So what you're doing there is you're starting with np.where, and you are picking the first thing. So the idea is that any price that's more than 30 lakhs, I believe this is 30 lakhs. So any price that is more than 30 lakhs or more than 30 lakhs is going to be termed as high. And any price that is between 30 lakhs and 20 lakhs is going to be medium, and any price below 20 lakhs is going to be low. So that's the kind of thing we want. And you can do that directly by using NumPy. So you just have to write down np.where and just check the price column. So data for price greater than 30 lakhs, comma high. So up to here, it's very simple. Be mindful of the brackets that we are using, okay, number of brackets and where we are putting those brackets. So we've simply stated that if the price is greater than 30 lakhs, we want that particular price to be converted to the categorical variable high, okay? Next, we are not closing this bracket, remember, we're just putting a comma and inserting another np.where, and again opening a bracket, and this time we are writing if the price is less than 20 lakhs, we want that row, that value to be replaced with the word low, okay? So there are two conditions. One is that the price can be greater than 30 lakhs, in which case it should be converted to high. Second is the price can be less than 20 lakhs, in which case it should be converted to low. And in the third case, which is this is kind of an if-else statement, okay? So if price is greater than 30 lakhs, make it high. Else if less than 20 lakhs, make it low. So there is one more category, which is that it is between 20 lakhs and 30 lakhs, in which case it's medium. You don't have to specify that using another np.where. So, and then you notice we are closing this bracket, and we're also closing the one that we began here. So I know that this statement looks a bit complicated, but once you understand it, I think it's going to be very easy to write it on your own, okay? So this data for frame is like that. We have changed the price into high, medium, and low. When you print it, you will see. Now, what is the benefit of this? We can convert this into, because these are ordinal values, right? High, medium, and low, they have some weight. So we could convert this into numeric data once again. Now, this numeric data might be hard to process, but converting this into numeric data of 0, 1, 2 will not be so hard. So how do we convert that? I leave that for you to explore by using the same kind of technique we used in encoding ordinal variables. You simply have to use the label encoder and pass all these values into the label encoder. And what it will do is generate these numbers for your values. So most likely, because it will assign values maybe based on alphabetical order, you might not exactly get what you want, but you could get something close. And if you're not satisfied with the way encodings are assigned, you could add your own encodings by using the replace function. Okay, you can explore that as well. So you can go through Pandas documentation, search for the replace function, and try it out. I leave that up to you to explore. So I hope you understood all this. I'll see you in the next video. Thank you.